it's sort of like the handshake or the protocol. Because if I'm talking and Jimmy's talking at the same time, we're not getting a lot of communication in. If I'm sending data, he's sending data, there's no way to communicate. So we handshake. We sort of agree that when I say something and I stop, it's sort of an indication of, okay, time for you to say something. And I stop, he sends something, says something, and I receive it, and then I send something back to him. And that's what this stuff is for. Clear to send, request to send. It's this handshaking that goes on between those two. So somehow the things have to communicate that not only am I sending data, I'm receiving data, but I'm ready to receive. Bring it on. All right. 8N1, 9 pins, receive, transmit, ground. But sometimes I talk too fast and you can't really hear what I'm saying. I can't really understand. So there has to be some way to control the speed at which this information is being sent. If I'm talking too fast and you're not listening fast, you're not going to understand what I say. Right? So I have to look at my bits per second and make sure that that's also correct. What do I call that?
Baud rate.
Baud rate. Call that my baud rate. Bits per second. Baud means bits per second. And so now I've got my controller and my GPS. Baud. B-A-U-D. Baud rate. B-A-U-D. We've got to make sure not only the information is coming in on this 8N1 format, and it's coming in on the right proper pin, but we've got to make sure it's coming in at the right speed. And typically, we set these things up. It talks about in here about handshaking. We set things up so that it comes. Oh, I'm just going to jump back a little bit. Most serial devices, as you read through here, if you've ever read through here, the things you pick up, and I kind of highlight. Most serial format is 8 data bits, no parity bit, 1 stop bit. You gotta reverse that. I said that earlier. Sorry. No parity bit, 8N1, 1 stop bit. Okay. And in here, the other important part of this is baud rates, data rates as they call it, bits per second. And so these are my data rates. Typically 4,800 bits per second, 9,600 bits per second is the way our things communicate. We could go slower. Well, not a lot of data is coming, you're not getting a lot of data. Or you could go faster, and sometimes if we go faster, the maximum distance to transmit gets smaller. 4,800, 9,600 are the two. But you got to make, for GPS and for other communication, but you got to make sure that you pick the right one. Because everybody a while back was running 4,800 baud, and all of a sudden some companies come out with 9,600 baud stuff. They think you need more information faster. And now you've got this, you go, is that 4,800 or is that 9,600 before I check it? And I got to program it to make sure we're talking at the same speed. So that's typical data rates and distances for RS-232, which is this 9-pin serial communications. I have one more thing to talk about before we just move on from this. And that has to do with null modems. Null modems. After we're done with null modems, we're going to talk a little bit about other sensors and then move into soil sampling. Null modems. And I don't have enough time to start that right now because it's kind of a communications protocol. And when things aren't working, put in a null modem and see if that works. Jeez, it's half the time. We'll talk about null modems next time.
Is that penal code that we see?
No, not exactly, but it's close to that. Close to that. The penal code is when the string is actually too long for it to go in. You just keep, there's too much information at one time before it stops.